chromatic aberration. Okay, so these are the defects in lenses. Okay, now if you have a convex lens, we place a convex lens like this, then we have white light coming in. So this will fall here. This is focal length of violet, and this is focal length of the red. Okay, so when the white light, so this you're incidenting white light. So when white light is incident, then violet you will get here and red you will get here.
Yes, sir.
Okay, so because this is happening because the refractive index of violet is greater than refractive index of red, or you can say the focal length of the red is greater than focal length of the
Violet.
violet.
Yes,
Okay,
sir.
okay, so yeah, so this is the fo focal length of the yellow light is equal to root of focal length of the red and the focal length of the
Violet.
violet. Okay,
The relation
so
between mu and focal length, sir.
mu and
Wavelength, sir. Wavelength.
no, no, mu is equal to c by v, and mu is equal to c by v is equal to n lambda. So
Uh-huh.
inverse relation.
Yes, sir.
Okay, right? So this
Yes.
is known as chromatic aberration. So if you send white light, then you will get image from here to here. So the image appears blurred. This we call it as chromatic aberration. To remove this defect, we use two or more lenses in contact in place of a single lens. In place of single lens, we use two or more lenses.
Yes.
Two or more lenses we are going to use. Okay. Next one is spherical aberration. Spherical aberration. What is this spherical aberration? Spherical aberration. We will get a spherical aberration due to marginal rays and paraxial rays. Now, let us take this as the lens. Now, if you take this as a lens, then here these are marginal rays. The rays which are far off, these are called as marginal rays, and these marginal rays you will get at one point.
Yes, sir.
And the paraxial rays or the rays which are closer
Yes.
to the principal axis. Okay, they will get at this point. Okay, so
Yes.
this our paraxial rays will meet at one point, and these are called as marginal rays. Marginal rays are meeting here, and these are paraxial rays. Paraxial rays are meeting at another point,
Yes, sir.
so the, the image is not sharp. Okay,
Yes.
so by spherical aberration can be reduced by using stops. Okay, right.
Stops.
So stops means you can place some opaque body here and opaque body here. So thereby you can cut the marginal rays out. So you will have only paraxial rays. So you'll get image as sharp.
Sir. Yes, sir.
Okay, right. Then then now if you have a lens like this, then this lens, if it is made up of two different materials, say this material uh, is here, okay, then if you incident light here, then how many images are formed?
One minute.
Only one image is formed. Only one image you will get.
Yes.
Okay, so but whereas if you have if you, this is a convex lens and you put different image, if you have different refractive index, say this is mu1 and this is mu2, this is mu3 and this is mu4, then you will have four different images,
Yes.
four different images you will be getting.
Yes.
Okay, right.
Yes.
Next concept is prism. Prism. Okay. Prism is a transparent medium bounded by refracting surfaces. Transparent medium bounded by refracting surfaces. Now this is prism. Okay. Now the angle here is called as apex angle. Okay, top angle,
Yes, sir.
or else this is called as angle of prism. Okay, angle of prism means apex angle you need to consider. You should not take this angle or this angle. Okay,
Yes, sir.
right. So now I considered a prism. Now for this prism, you will have, say this is the normal. So this is angle of incidence. Okay, then it, as it is entering from rarer medium to denser
Okay.
medium, it will move towards the normal.
Yes.
Will move towards the normal. So let us call this as R1. Then here you will have one more normal here. Then here this angle is R2. As it is moving from denser
And
medium to
that's
rarer medium,
away from.
it bends away from the normal. So this we call it as E. This I is called as incidence angle.
Yes.
This I is incident angle. This angle is
Emergency.
emergent angle of
And
emergence.
yes, sir.
Angle of emergence. Okay, now this R1 plus R2 is A. R1 plus R2 is equal to
Yes.
A. Okay, now this if this prism is not there, then the ray would have gone like this, but
Yes.
it is going in this direction, so that means this is deviation.
Yes.
Okay, and that deviation that deviation is equal to I plus E minus A.
Yes, sir.
I plus E minus A is deviation, and R1 plus R2 will be equal to A.
And yes.
Okay, okay.
Yes,
Now,
sir.
okay. So now if you draw a graph with a different angle of incidence, for one angle of incidence you will get deviation as minimum. That we call it as angle of minimum deviation. When this is at a minimum deviation position, minimum deviation position, minimum deviation position, what you can see is R1 will be equal to R2. When R1 is equal to R2, then R1 plus R2 is equal to A. So this will become 2R is equal to A. Then R is equal to
A
A
by 2.
by 2. R is equal to A by 2. This is for minimum deviation.
Yes.
Okay. And the minimum deviation, for minimum deviation condition, you can see one more thing, that this line is parallel to the base.
Yes,
Okay,
sir.
let us say this is AB, that AB line is parallel to the base.
Yes.
AB is parallel to the base. AB is parallel to the base. Okay, then what else we have? Um, yeah, so I will be equal to angle of incidence will be equal to angle of
Emergence.
emergence. So now the deviation is equal to, original formula is I plus E
Minus
minus A. So here I will write I plus I
I
minus A. So that is
2I.
2I minus A is deviation. Okay. So this, if I simplify, delta plus A by 2 is equal to I.
Yes.
Then what we can do is we just apply the Snell's law over here and then let's check what we get. Now, if I use the Snell's law, then what we are going to get if we use Snell's law? Snell's law is now mu into sin I, mu of air into sin I is equal to mu
M.
refractive index of this medium
M. Mu.
into sin R.
R. Yes.
Okay, sin R. But here mu is 1.
Yes.
You know its value is 1 because it is air. So mu is equal to sin I by sin R.
R.
But
Yes.
we know that it is delta plus A by 2. This is minimum deviation. Minimum deviation. Okay, this is minimum deviation. So mu is equal to, so I can write here mu is equal to sine, in place of I, what we
Delta.
substitute?
Delta
Delta
minimum plus
A
A by
plus
2.
delta minimum plus 2. In delta minimum by 2. A plus delta minimum
By
by
2.
2
D.
by
Sin R.
sine
R.
R
A,
is,
A by
sine
2.
R
Yes, sir.
is nothing but A by 2.
A
So
by
this
2.
is the formula for minimum deviation.
Sir, when I is equal to E, we can write in place of I E also, no,
In
sir?
place of E, right. Okay,
Yes.
right. So these formulas you need to learn are very important in solving
Yes.
the problems.
Yes, sir.
Yeah.
Yes, sir.
Now, if you look at the formula, I look at one problem. NEET 2021, he gave a question that if you take a uh, prism like this, and the incidence is perpendicular to the surface. Okay, then if the angle here is 60 degrees,
Yes.
okay, and refractive index of the glass is root 3,
Yes,
is
sir.
root 3. Then what is the value of angle of emergence? We have to find the angle of emergence here. Angle of emergence, how much? This question is given in NEET 2021. Okay.
Yes,
Now, here the angle of incidence is 0 because this is along the normal. Angle of incidence is equal to 0,
zero.
right? Angle of incidence is equal to 0. R is also, R1 is also 0. I1 is equal to 0. R1 is equal to
Zero.
0. Okay.
Yes,
So now the refractive index here is given as
root 3.
root 3. Okay. So first of all, A is equal to R1 plus R2. A is equal to R1 plus R2. Now here this is 60, so this is 90. Angle of the prism is apex angle, so apex angle is
30.
30. So 30 is equal to R1 is 0,
0.
so you
Yes,
put 0, so you'll get R2 as 30
yes, sir.
because R1 is 0.
0.
Now once you got R2, then you write, okay, so it will come straight down like this, straight
Yes,
it will
sir.
come down, and that's the normal. So this is say R2,
Two.
and the light ray bends
And away from the north.
away from the normal. Okay, so this is emergence. So
Yes,
that emergence angle we need to calculate. Okay, now here we will apply the Snell's law. Mu, mu of glass into sine R2, because here the angle is R2 and
two.
refractive index is mu g. So mu
Mu,
g sine
mu 3.
R2 is equal to mu of air into sine E, sine of angle of emergence. Then this is root 3. Sine R2 is sine 30. Sine 30 is
5.
1 by 2. That is equal to mu A
Mu
is 1. So that is equal to sine E. So E is equal to sine inverse root 3 by
root
2.
3 by 2.
2,
Yes,
that
sir.
is equal to 60 degrees.
Yes, sir.
So that is our answer. Emergence angle is 60 degrees.
Yes, sir.
Okay.
Yes, sir.
Right. Understood this problem?
Yes, sir. Understood, sir.
Okay. Right. Now next concept is dispersion. Dispersion through prism. Dispersion through prism. So you place a prism. Okay. You place a prism and then incident white light. Say this is white light. White light. Then it is going to split into different rays like this. Okay. And you get We'll get that on a screen. Okay.
Yes, sir.
So this will be like WebGR.
Yes.
Okay.
Yes, sir.
Violet, violet, indigo, blue, yellow, red.
Yes, sir.
GYOR.
R. Yes, sir.
Okay. So the colors we'll get. The splitting of white light into its constituent colors is called as dispersion of light. Dispersion of light. Dispersion of light means splitting of white light into 7 colors.
Yes, sir.
Splitting of white light into its constituent colors is called as dispersion. Okay. Now, thing is, next one we will discuss angular dispersion. What is angular dispersion? Angular dispersion. In angular dispersion, get angular dispersion is denoted by theta. Okay. The angular separation between extreme colors. So theta is equal to deviation of violet minus deviation of red.
Red.
Now, if you see here, now that is actually this is how it should go,
Yes, sir.
but it deviated, violet deviated like this, so that
Yes.
is delta V, and the red deviated like this, that is deviation of red. So the difference in the deviation is called as angular
Angular dispersion.
dispersion. Now we know that the deviation the deviation value is equal to, formula is mu minus 1 into A for small angled prism. For
An angular prism.
small angled prism. Small angled prism means the angle of the prism is say somewhere less than 6 degrees.
Yes.
Then we call it as small angled prism. For small angled prism, deviation deviation is equal to mu minus 1 into A.
A. Yes, sir.
Okay, so here for violet, we can write deviation of violet is equal to refractive index of violet minus 1 into A. So I'm going to substitute this one. Refractive index of violet minus 1 into A minus refractive index of red minus 1 into
Into A.
A. So that gives us mu V minus mu R into A,
To
because
A.
here minus A and minus of minus plus A will get cancelled. So you'll get a mu V minus mu R into A.
A. Yes, sir.
Right. So that is angular dispersion. This angular dispersion depends upon two things. One is refractive index and other one is A.
Prism. Yes, sir.
Depends on. Okay. Right. Then dispersive power. Dispersive power. What is dispersive power? Dispersive power is omega. Omega is equal to theta by delta y. So that is equal to mu v minus mu r by mu y minus 1. Okay. So it depends.
So mu I
Mu y. Mu y is the
is
average of mu v plus mu r by 2.
Yes, sir.
Okay. So it depends on material of the prism mu, and it doesn't depend upon the angle of prism. It depends only on mu material of the prism,
Yes, sir.
and it doesn't depend upon the angle of the
Prism.
prism.
Yes, sir.
Okay. Right. Next concept is scattering of light. Scattering of light. What is scattering of light? See, the sky appears blue in color because of scattering.
Yes.
Sky appears blue. Sky appears blue, blue in color because of
Scattering of.
scattering. Now let us see what is scattering. See, the we have mostly in our atmosphere we have nitrogen and oxygen
Yes.
molecules in our atmosphere, right? So these nitrogen and oxygen molecules have got same size, nearly same size as that of blue light. So
Yes.
what they do is they absorb blue light and emit blue light.
Yes, sir.
They absorb blue light and emit blue light.
Blue light.
So that's why the sky appears blue in color. Okay. Generally, the red light, the red light is used in signals because no, because this red wavelength size molecules are not there in our atmosphere. So
Yes.
no molecule in air is absorbing
Red
red
light.
or and reflecting or emitting red. So that's the reason why it is least scattered. Red light is least scattered. So that's the reason why it is used in
Signal. Static
signals,
signal. Yes.
traffic signal. Okay. So
Yes.
yeah. So these are the concepts, scattering of light. Now, okay. Now one more concept that now if you have a hollow prism, see the prism is like this, then the ray will just move like this. Okay, the light ray is going to travel like this. Now, so so if a is not equal to 0, the deviation should be equal to 0 because it doesn't deviate, it goes just straight.
Yes, sir.
Okay.
Yes,
Now,
sir.
if you are given a part of prism, say for example the prism is given like this. Say the prism is given here like this. Say this is 60 degrees and that's 70 degrees, and you have like this. Then
Yes.
what you do is you can just construct the full prism, and then you can solve the problem.
Yes, sir.
Okay.
Yes, sir.
If some part of the prism is given, you can construct full prism and then you can solve the problem.
Sir.
Okay, right?
Yes, sir.
The next concept is optical instruments. Okay. Now in this we have a islands, islands like this, and then the islands is supported by ciliary muscles. Okay.
Yes,
Then
sir.
you have like this, and the retina is actually a canopy of the optic nerves.
Canopy meaning
Canopy means it's it
bundle.
bundle or yeah, bundle you can say. Okay,
Yes,
so canopy.
yes, sir.
So this is that's
No,
optic nerve. So this retina acts like a screen, and
yes,
here the ciliary
ligaments.
muscles, the ciliary muscles, the ciliary muscles change the focal length of the lens, eye lens, because
Yes, sir.
if now the ciliary muscles get tightened, then the radius of curvature decreases. Okay, by
Yes,
changing the radius of curvature, it is changing the focal length of the lens.
yes, sir.
Okay, so if your object you are looking at different objects here, then focal length it will adjust the focal length such that the image will form here. Okay,
Right.
so this is U, and V is fixed. V is fixed. So it
Yes,
will
sir.
adjust the focal length such that V it will fall here.
Yes,
Okay,
sir.
so the eye lens actually will behave as a lens of refractive index 1.43 7. Then you get a real inverted image over here. On the retina, you get a real
Inward.
inverted image. Okay, and the brain will make it upright. Okay,
Yes, sir. Yes.
okay. Now next one, the term power of accommodation. Power of
Accommodation.
accommodation. What is power of accommodation? The ability of the eye lens to see near objects as well as far off objects.
Yes.
Okay, so you can see near objects as well as
For objects.
far off objects. The ability to see near objects as well as far off objects is called as power of
Accommodation.
accommodation. Power of accommodation. Okay. Now we have defects in eye. One is called as myopia. Myopia. Let's see what is myopia. Now myopia is also called as short-sightedness.
Cited.
Short-sightedness. Short-sightedness. Myopia is also called as short-sightedness. That means you can see objects near objects you can see clearly. The
Yes, sir.
objects are near, you can see clearly. Far
Yes.
off objects, far far off objects appear blurred.
Blood. Yes, sir.
Blurred. This
Yes, sir.
defect is called as myopia.
Myopia.
Okay.
Yes, sir.
So the reason for this is the focal length or radius of curvature of the lens got reduced.
Yes.
Okay. Or power of the lens increases. Okay.
Sir, ciliary muscles contracted, sir, then.
Uh, no, actually here radius of curvature gets reduced. Okay. Or
Oh,
distance between the eye lens and the retina either it should increase. Why? Because here now in myopia what happens is here this is the lens.
Yes,
Then actually it will fall here.
yes, sir.
Now here you have retina, but it is falling here.
Yes,
Okay,
sir.
so imagine that this is retina, then it is falling here.
Yes, sir.
Okay, so you need some diverging lens to actually to able to see the object more clearly.
Yes, sir.
Okay, so you have to use a diverging lens. That means you have to use a con
Concave lens.
concave lens so
Yes,
that
sir.
it diverges a bit and it will fall on
Retina.
retina.
Yes, sir.
Okay.
Yes, sir.
Now, the other defect in our eye is hypermetropia. 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 In hypermetropia, you can see distant distant objects. In hypermetropia, distant objects you can see clearly, but near objects,
Blur.
near objects, it will appear blurred.
Yes.
Okay, in this defect, so here this is eye lens, this is eye. Now the image is falling far behind
And
the
retina.
retina.
Yes, sir.
So now you have to use more converging lenses. So you have to use convex.
Convex
If you use
lens.
convex will converge and
On the
make it
retina.
fall on the retina.
Retina.
Okay. There is another defect called as presbyopia. Presbyopia. What does presbyopia does?
Near.
So in this defect, both near and far objects are not clearly visible.
Yes.
Not clearly
Yes.
visible. Not clearly visible. Okay. So this is due to old age.
Yes, sir.
Old age, when people become old, the ciliary muscles loses the stiffness, thereby they cannot change the focal length of the eye lens. So you will have both the defects,
Yes, sir.
myopia and hypermetropia.
Hypermetropia. Yes, sir.
Yeah, both you will have. Okay, so yeah, this defect can be removed by using bifocal bifocal lens. This defect can be removed by using bifocal
Bifocal.
lens. Okay, now next concept is microscope. What is a microscope? Microscope, say this is a lens, and here you place an object. This is focus, then you get image here. Okay, when you place between focus and optic center, you get
It's beyond
virtual
focus.
virtual erect and enlarged image you will get.
Yes, sir. At infinity will get, sir.
And now at focus if you place, I'll get it infinity. This is placed between focus and optic center, na?
Yes, sir.
Focus and optic center, what you will get? You'll get
Virtual.
virtual,
Correct.
virtual, erect, and
Magnified.
Magnified image. Virtual, erect, and magnified image. Okay. The magnification is formed at D. D means what is it? D?
Type.
Least distance of least distance of distinct vision.
Yes, sir.
Okay, least distance of distinct vision. So actually it is 25 centimeters. So before this one, if you are bringing some object uh, before this one, I mean less than 25, then you can't see it more clearly. Okay, so
Yes,
here we can see more clearly at 25 centimeters. This we call it as strained. Strained. Eye is strained.
yes, sir.
Eye is strained. And so now the magnification, if the image is forming at least distance of distinct vision, then magnification is 1 plus d by f.
Yes, sir.
Okay, and magnification to
Infinite.
infinity, if it is forming at infinity, it is d by f. d by f. d by f is minimum. This is maximum. Why? Because you are adding 1 plus, that means this magnification is more and this magnification is less. When it is forming at infinity, infinity if it is forming, then it has to form here, right? Focus. Okay, so it can form at infinity. Okay, now next one is, this is about microscope. So these two formulas we need to remember.
Yes, sir.
Okay, after microscope we have compound microscope. Okay, compound microscope. Compound microscope. In compound microscope, what we have is, say this is principal axis. You have one lens here, and here you have another lens. Now you might have seen that the focal length, so the lens which is closer to the eye is called as eye lens, and which is closer to the object is called as objective.
Object.
Objective. Now I'll place an object over here. Okay, say let us take that as A B. So it shows that whether it is inverted or not. Okay. So now the one ray diagram, if you're drawing, then it will show like this, and you focus like this, and then it forms an image here. Okay. Now the
Yes,
other one you have to, now other one you have to draw through the optic center and here. So the image is forming here, and this is image B dash and A dash.
sir.
You have to see that this forms between the focus and optic center of the eye
I
lens.
know.
Then
Yes, sir.
if the object is between focal and focus and optic center, it forms a virtual erect and magnified image, right?
Yes, sir. Yes, sir.
Yeah, so here it forms a virtual enlarged image. Of course, here it is inverted.
Yes, sir.
Okay, inverted because this got inverted. Okay,
Yes, sir.
so for the first one is forming an image. This image will serve as an object for the eye
I
lens,
know.
right? So you get an image here.
The image is the object for islands, sir. No,
This image is object for the islands.
islands. Yes, sir.
Okay, now here you can write here the focal length of the islands is greater than focal length of the objective, and the diameter of the islands is greater than the diameter of the objective. Okay, the final image now, if it is forming at least distinct distance of distinct vision, then that is going to be minus V naught is image distance. So from here to here, this is V naught. So V naught by U naught. U naught is this
Object distance.
distance, object distance. Okay, now this is like a microscope. It is acting like a microscope. So you can write that formula 1 plus D by F. Here, Fe.
E, sir. What E?
Fe is focal length of the islands.
Yes, sir.
Fo is focal length of the objective.
Yes, sir.
So now, if you take magnification, if it is forming at infinity, image is forming at infinity, minus V naught by U naught. Now that will become D
E by
by
F.
Fe.
Yes, sir.
Okay. Now we have one more thing called as length of the tube. Okay, we'll discuss another thing called as length of the tube. Now, what is the length of the tube? Length of the tube is the distance between these two.
Yes, sir.
Okay, so now this distance between these two is nothing but this is V naught, and this is nothing but U
E.
object distance, right? So length of the tube is equal to length of the tube is equal to, yeah, how much? V naught plus V
E.
naught plus UE.
E.
Okay, so this is when the image is formed at D.
Yes, sir.
L is E. Okay, when this is at D. If the image is formed at infinity, if it has to fall at infinity, then this image UE should be equal to FE. Okay, if the image is formed at Fe, then object, the image of this acts as an object for the island. So if this is formed at focus, then image you will get at infinity. So
Infinity.
the length will be equal to V naught plus UE is equal to Fe. That is the length of the tube. Okay, so okay, now the magnification. The total magnification m is equal to, what is the magnification? If somebody asks you, then you have to always say magnification of the objective lens into magnification of the eye lens. Okay, now see here what we have done is that only this is objective magnification, this is eye lens magnification, this is objective magnification, this is eye
Islands.
lens, eye lens magnification. Okay, that is how we did this. Okay, that is about compound microscope. Now we will discuss the uh, terrestrial astronomical telescope. Okay, this is compound microscope. Now we will discuss terrestrial telescope. Terrestrial telescope. And terrestrial telescope, astronomical telescope. First we will discuss, then we will discuss terrestrial telescope. Astronomical telescope. Astronomical telescope. In astronomical telescope, first we keep one objective and other one is the eye lens. You can see the difference.
Yes, sir.
What is the difference you have observed?
Objective lens is larger, sir.
Objective lens is larger. Focal
Yes.
length of the objective. Focal length of the objective is greater than the focal length of the eye lens.
Yes, sir.
Eye lens. Now, why we have done is because now when you're looking at a star, you have to allow more light into the telescope. That is possible when you have a bigger one, bigger
Yes,
lens as the objective lens.
yes,
Okay, so here you can see that the diameter of the objective, okay, that is also called as aperture. So the aperture of the objective lens is greater than the
diameter of eye lens.
diameter of the eye lens, or else you can say aperture of the eye
Aperture
lens.
of eye lens.
Okay, now here you will get rays from infinity, not from the object is at infinity, so you will get rays like this. And so when it is passing through the optic center, then let's say it comes like this. So this one, so it has to bend slightly, and then it's here. Then this is okay. This is the image. Now let us call that. Now here, now the intermediate image is real. Okay, it is inverted
Right?
and it is small size. Okay,
Yes, sir.
that is called as real because you're at infinity. If the rays are coming from infinity, the image is formed at focus. At
Yes, sir.
focus, you will get a diminished image.
Yes, sir.
At focal length of the this is objective, and
Eye
this is what, this is eye lens. So if you place an object at infinity, then image is formed at focus.
focus.
So that is the focus over there. That's focus. Yeah. So yeah. So this is focus. Now yeah. Now here what we can see here is this is focal length of the objective.
Yes.
Now if this is this distance, this image acts as an object for the
Island.
eye lens, and the eye lens, if it is between focus and pole, it forms an virtual image, right?
Yes, sir.
So it forms a virtual image like this. Okay, so this VE is nothing but D. Okay, the image distance is at a D. Okay, now the magnification final, this is the final image. The final image is going to be virtual
Inverted.
and inverted and enlarged or magnified. Okay,
T
now
is up.
the now when we yeah,
T is aperture, sir.
D is also called as aperture, diameter or aperture.
Yes.
Okay, Now the magnification we'll see. Magnification is what we write M. The magnification, if it is falling at least distance of distinct vision, then magnification of the objective you have to write F naught by Fe, F
Yes.
naught by Fe,
Okay.
because you are getting image at F naught, V naught is F naught,
Yes, sir.
right? So F naught by Fe into 1 plus Fe by D.
Yes, sir.
Okay, that is MD. Magnification at infinity is equal to minus F naught by Fe.
Okay.
Okay, then you have length, length of the length of the telescope. Length of the telescope is length of the telescope is LD is equal to F naught plus UE.
E
F naught plus
plus
UE.
U
Now L infinity is F naught plus Fe.
E S.
Right? UE is equal to Fe. And if
Yes.
you then you will get at infinity.
Yes, sir.
Okay.
Yes, sir.
Right. Done. Tomorrow we'll continue. I'm in on 12th. Okay.
Yes, sir.
I'll
Okay,
let,
sir.
yeah. Right. Bye.
Okay.